My name is Lucia Pereira. I'm a researcher at the Department of Scientific Research in the British Museum, and my research project here at the BM is about the applications of a relatively new type of laser called erbium laser, which is mostly applied to paintings. So the removal of old varnishes, overpainting from both easel and mural paintings. So my goal is to investigate the applications of lasers in conservation. In conservation, cleaning is one of the most common operations and also one of the most challenging. You can imagine that a conservator will need to face really difficult situations as removing a really insoluble varnish from a very delicate, fragile paint which is flaking on the surface. So lasers could be a good alternative because they are non-contact tools, so we don't need to touch the surface of our object. They are very precise, it's highly directional. We can have a very small beam on the surface that we are cleaning. They are also quite selective depending on the materials you've got.
My name's Elizabeth O'Connell and I'm a curator in the Department of Ancient Egypt and Sudan. The painting currently undergoing conservation and scientific research belongs to about the 6th century. The wall painting shows 3 vignettes from proto-martyrs of the distant biblical past to international and regional martyrs of the more recent past. The wall painting was discovered in a villa, the Daniel Villa as the excavator termed it, in 1914. From the research project, we already knew just how heavily the wall painting was restored. This is an image of the painting in mid-conservation after it arrived at the museum, and you can see it arrived in pieces, and the 1:1 scale drawing was used to restore it before it went on display in the galleries at some point before 1921. Conservators have carefully investigated the different layers of restoration and their reversibility.
My name is Tracy Sweek. I'm a member of the Stone Wall Paintings and Mosaics section here at the Department of Conservation. So our first thing was to see how much of the original painting exists, and a lot of this surrounding area and some of this central sections are heavily painted with the restoration paint in the 1950s. So that gave us a lot of opportunities to try tests and testing areas on the surrounding area without infringing on the original wall painting itself. We did some trials and tried a combination of water alone, acetone, and we also used IMS. They worked in removing the surface dirt, but they didn't actually do anything to the alkyd paint at all.
I'm Stephanie Vasiliou. I'm a conservator here in the Stone Wall Paintings and Mosaics Conservation Department. After we did the initial poulticing tests, we decided to work alongside science testing the erbium YAG laser. The laser itself is used quite a lot in the past on paintings, easel paintings and also mural paintings. So we thought it might be a good machine to try on the painting. We did dry testing, so we just did a pass with the laser at increasing energies to see sort of what effect we could get. We then also decided to try and test it alongside solvents. We tried various solvents and we actually found that the most effective treatment was doing pass with the laser and then a swab with isopropanol.
What we do before treating a real object, of course, I need to make sure that the treatment is first efficient and second safe for the materials. So I use a reference collection of samples to experiment first. So here some of these objects are very old, so that's actually good because they are naturally aged, and that reproduces better the reality when you are treating an ancient object. So it's very useful as a resource for preliminary testing to make sure that when you actually go and use your laser on the real object, you have everything under control. Now I'm going to show you the typical setup that I use for the laser tests on the samples. So one possible goal is to investigate whether the laser is efficient to remove a particular material. I generally place my sample here on a platform that I can lift. I monitor everything with a digital microscope so I can follow what's going on the surface here on the screen. So now we can get started. So here you can see how after the treatment we can clearly see a difference between the coating, and this is the area that I have just irradiated, where you can see we managed to thin that coating, and now the stone is much more visible, is coming to the surface. At the moment we are at one of the science labs where we have the SEM EDX. It's a special type of microscope that gives us a huge resolution, so we can investigate the surface of the objects, and we can also do chemical analysis. So what I generally do is, before irradiating the objects with a laser, I tend to investigate whether the original materials on the surface might be sensitive to the radiation. So I'm going to place my samples inside the chamber. This is an example of the investigation of the surface of an object. So this is before the irradiation. You can see the organisms covering the surface of the limestone. And this is after the laser irradiation. So you see how the treatment has destroyed the body of the biological colonizers that were growing there. And this is the surface of the limestone after swabbing. So after irradiating with the laser and applying a cotton swab with a mild solvent, just to remove the residues. So what I have here is a sample from the coating that is covering the wall painting we've seen before. We want to identify what's the material to see if the laser will be able to remove it. So I've taken a small sample. So now I've got my tiny sample in the center of this diamond cell, and I'm going to place it under the objective of the microscope. So this is FTIR, Fourier Transform Infrared Spectroscopy, and what we are investigating is how the molecules vibrate that we can identify in the spectra, and then determine what's the material that we have in our sample. And as you can see here, this is an example infrared spectrum from shellac, which is a resin excreted by an insect, and it's very commonly used to coat, for instance, wood or musical instruments, and sometimes wall paintings were covered with shellac. And you can see how it fits. So now we know what's the coating that is covering our object, our wall painting, and we know that it's possible to treat it with erbium laser. It will absorb radiation at that wavelength.
Now, the treatment that we're going to be carrying out, now that we have determined our parameters, is that we are going to reduce the overpaint around the outside, effectively remove it from any of the surrounding areas. Where it encroaches onto the original painted surface and it's actually a restoration, there is no original paint beneath the restoration paint, we're going to leave that. So we're going to try and lift that paint, lighten it so it becomes much more in keeping with the original painted surface. And so it's sort of working between the two extremes of complete removal where it's just on modern plaster, and then lifting the paint where it actually is a restoration, so that ultimately we can then carry out further conservation to bring the whole painting back together in a much more sympathetic way. So we are wearing goggles, just because when you're working with a laser it's always good health and safety practice to wear goggles. We also have extraction here. This is to protect us from inhalation of any of the fumes coming off of the solvents that we're going to be using. I'm not going to be wearing gloves because I'm going to be handling the laser itself, but Tracy will be wearing gloves as she's the one that's going to be interacting with the solvents. So we just hit ready twice, and once we hear that sound the laser's ready to be used.
As a conclusion, we can say that as technology evolves and our knowledge about the materials also increases, problems that in the past were impossible to address suddenly become possible. And we have now the possibility of recover objects that were sometimes beyond conservation. Nothing could be done. So we might be able at some point in the future to conserve objects that at the moment seem impossible.